T-minus 1 minute. T-minus 30 seconds. We are go for launch. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Next up, we're going to talk about plant growth in space, things happening inside this lab to help sustain our presence on the moon and beyond. Welcome back. We are coming to you live once again from NASA's Kennedy Space Center. I'm Joshua Santoro with NASA Communication here in front of the beautiful Space Shuttle Atlantis. A beautiful co-host, as always, the last vehicle to take humans into low Earth orbit from America. And we are getting ready to do that again in just 2 short days. Philip, my guest today, or my co-host today, rather. Philip, thanks for joining me.
Thank you so much. My name is Philip Hargrove, and I'm with the Launch Services Program. I'm really excited to be here today. As Joshua said, we're getting ready for human spaceflight from American soil again. And for today's show, we're going to be talking about one of NASA's efforts to sustain life in space by talking about veggie. So I want to encourage everybody watching online to submit your questions. We normally would be able to bring you on to center for the NASA social so you could, engage with us and ask questions and see all of these really cool things here. But just because you can't do that, that doesn't mean that you can't be engaged. So please be a part of the discussion, and we're excited to talk to our special guest today.
Yeah, I mean, such a good point. 2 things, obviously, just the virtual aspect of this and keying on the sustained presence beyond Earth. That's a big part. Hopefully you've heard that NASA is going back to the moon, but it's not just a camping trip, as some might say historically is what the Apollo program was like. This time, we are going to stay there for longer periods of time. Right. And just like you're coming to us virtually, our guest is as well. So let me go ahead and introduce Dr. Gioia Massa. Gioia, thank you as always for contributing to our outreach efforts. How are you doing today?
I'm great, Joshua. Good to be here with you and Philip and to talk with people about our space production work at Kennedy Space Center.
So obviously, I think hopefully people understand that when we talk about growing plants in space, this isn't just throwing seeds in the ground and watching them grow. There's a lot more to it than that. So I want to let you kind of introduce a little bit about what you're doing and kind of what this big picture is as far as plant growth in space.
Well, we are working on being able to grow crops for the crew to supplement the packaged diet in the near term. And this will get really important as we go on to the moon and on to Mars beyond that, because the stored food will lose nutrition and it'll lose quality over time. And so we need to ensure that the astronauts stay healthy by giving them supplemental fresh produce. And then as we go and stay longer, we'll be able to grow more of the food that they're going to need to eat and survive.
Awesome. And you brought along a few videos today. There's 4 total. We're going to try and get through all these. Want to take questions like Philip mentioned as we go. Let's jump right in here. Obviously, this one focusing definitely on that plant growth in space. So Gioia, tell us what we're watching as we check out this video.
Sure. So this is on the International Space Station where we have veggie hardware. So veggie is one of the 2 plant growth chamber types that we have on Space Station. And we've done a lot of different crop experiments with veggie, or I should say the astronauts have. We have the zinnias that Scott Kelly grew, and these we had some problems with related to the watering, which we'll talk about a little bit soon. But Scott took over as an autonomous gardener. He was really able to do a wonderful job to bring the zinnias back to life, get them to flower, and he even did the first on-orbit flower arrangement ever, which is pretty awesome. We were really thrilled by that. We got a lot of these flowers back, and were able to grow daughter plants from the seeds that were in the flowers. And here you'll see a beautiful shot of his flower arrangement. We've also grown a number of other types of crops, leafy crops primarily that the crew could grow and eat. And we monitor everything from our ground station, our experiment monitoring station here at Kennedy Space Center, where we get over-the-shoulder video. We also get great photos back from space. And we run ground control experiments in our chambers so that we can mimic what the astronauts are doing and help answer any questions if they have problems or encounter challenges. We are a wonderful team. The veggie team is really knowledgeable, very supportive, and reacts very well to problems because we've had quite a few. It's not easy growing plants in space, but we do our best to get happy astronauts that can eat produce, and we do a lot of ground tests leading up to that so that we can ensure that everything is safe for crew to eat. So yeah, veggie's been really successful, in spite of some of the challenges that we've dealt with. And we'll be happy to answer questions on that. Hopefully we'll grow some tomatoes in the future.
Yeah, I want to get into some social media questions, but I wanted to ask you there's probably a dozen things I could ask you about just that short video, but I want to kind of key on the fact that you mentioned you have a small team, and you all are responsible for growing plants and flowers in space, like on the space station. Like that's incredible, Gioia. Like that's how this works, right?
Yeah, it's awesome, and it was a lifelong dream of mine to be here, and so we plant the seeds. You'll get to see some of that in one of the later videos. We do selection of the crops beforehand, and we're really trying to figure out what will grow well in this unique environment of the space station. It's without gravity, without natural convection, and we have humans and plants and microorganisms all living together.
Yeah, Gioia, that's a great segue into some of the first questions that we got from our online audience. Can you tell us about some of those future crops that are going to be on veggie?
Sure. Yeah. So we've got some on board right now to test, some varieties of leafy greens, including a new variety that we've never grown, which is an Amara mustard. It kind of tastes like a meaty flavor almost. We can call it a steak plant is kind of our fun common name for it. We hope that the astronauts will really enjoy that one. We're working on peppers for the advanced plant habitat. I'll show some shots of that in a little bit. And we're looking at tomatoes for next year, as well as other varieties of leafy crops. There's no way to cook anything on space station, so we're only looking at things you can pick and eat fresh right now.
Awesome. So as we think about you can't cook things in space, at least not yet. I'm sure someday somebody's going to make that happen. Hopefully people have seen movies like The Martian, which was put together with the help and support of a lot of NASA scientists. So obviously we saw a lot of potato usage there. Is that just, hey, you can eat raw potatoes, or is that like, hey, the future of we can actually cook potatoes now?
Well, as soon as you have a microwave or an oven or some, fairly straightforward way to cook things, and they do actually have a small oven on space station for cookies, but it took about 2 hours to bake one chocolate chip cookie. So I think it would be about 24 hours to do a baked potato probably. But as soon as you have something that would work well, potatoes are a great crop, and we've studied them at Kennedy Space Center for many, many years. They're very productive, and they've got, good calories and a few nutrients in there too.
Let's do one more question, and then we'll go back to the next video.
Great. So there's a lot of questions about the methods that are being used to grow these plants. Can you talk about some of the challenges that you're particularly having to solve to make this happen?
Well, that's a great segue for the next video. Our biggest challenge is water. Watering plants in space is really very hard because water is kind of a blob, and water and air don't mix well, but plant roots really need both water and they need oxygen. So we'll see some videos on that. You know, other challenges are really just trying to keep the environment for the plants suitable. So keeping the light the right levels, keeping the humidity high enough that the plants can grow well, but not so high that fungus grows. So it's a lot of finding happy mediums.
Yeah, you mentioned the segue. Let's go ahead and take a look at this next video.
Water behaves kind of strangely. It forms, blobs, and it coats surfaces, and water and air don't mix well. And so we're looking at a lot of different ways to water plants in space to try and get not too little water, not too much water. We don't want to drown the plants, and we don't want to dry them out.
Lettuce garden, and as you can see, they're growing wonderfully. Now, in zero gravity, nothing's going to make the water fall down over the plants like it might when you water your plants on Earth. So here we have to use something special. We have to use a bag with water in it and a syringe. Yes. What we do is, every little plant has a tube, and carefully connect the tube to the plant. Carefully connect the tube to the plant. Like that. Then we use our syringe to pull up the water from the bag. The water out, it's going to go into this little bag that has all the roots of the plant. Go, watering the plant. We even get to eat the lettuce when it's all grown and harvested. There's one plant watered. I just have to do that a few more times, and I'll have the whole garden watered. Thanks for watching. Goodbye from the International Space Station.
Awesome. So that video showed us or gave us some insight into what the astronauts have to do to make these plants grow. Do the plants themselves behave differently? Do they grow in any unique ways in space that we might be surprised by?
Well, there are a lot of changes on the genetic signaling level. And so we have a number of researchers around the world who study, plant responses to gravity and how plants sense the different environment of space. But when we're looking at the whole crop level, as we're mostly doing in the veggie group, we don't see too many differences in growth. Some of the plants do look very different between flight and ground. We've had one variety of lettuce that just had a totally different shape, growth habit. But most of the plants grow pretty normally if we can get just that right amount of water and the right temperature and the right amount of light. So the trick is getting that environment pretty good. But yeah, Christina did a wonderful job showing the watering process. For veggie, it's pretty manual. The astronauts have to go and add that water. We hope to become more automated with our watering systems in the future.
Okay. Awesome. So what type of lighting do they use? You talked about the environment in terms of the water. We could see sort of, I think there was some blue and some purple kind of looking lights. It looked like there was 2 different sections. Is there any unique or particular type of lighting that you use to support the plants?
So veggie has red, green, and blue LEDs, and we can control the ratio of those. And so that experiment that you were looking at was Veg 04, which was conducted last fall. And that one was looking at the difference between those different kind of a blue-rich treatment and a red-rich treatment in veggie to see how that impacted how well the plants grow, how they tasted, how nutritious they are, and if their food safety was different. And so we're still analyzing all of the data from that mission. But in general, plants are very sensitive to light, and you can kind of dial it in differently for different plants. Our other hardware up there, our advanced plant habitat, also have white lights and far red LEDs. And so we can really play with the color spectrum and tailor it for different plants.
So, Gioia, just thinking about all the challenges you hear, talking about customizing per plant, per flower, how much of this process is executing good ideas and how much of this is just discovering new things for the team?
Well, as you said earlier, we have a pretty small team and we're kind of limited on what we can do. So we look at the greater scientific groups around the world to see what they're finding and help apply their finding to our research. We can't test every single variety under every single set of conditions. We did have a postdoctoral researcher with our group who specialized in lighting, and he did a lot of custom testing, as we were really able to learn from his work to apply it to what we're doing now. But we also keep up with what's going on everywhere else to try to figure out what's going to work best in the space environment.
So can you tell us how this translates from the space station to the moon or Mars or wherever else humans may go?
Right. Well, you know, on the space station, microgravity is a big challenge, and especially from the watering, as you saw with that great water video with the washcloth being wrung out. You know, water is just so strange without gravity. When we get on the moon, we'll have 1/6 G, a little bit of gravity, and that will probably make it a lot easier to water your plants. And Mars will have 3/8 gravity, and so that will probably be even easier still. But we want to develop systems that are going to work in all of those different environments. So we're doing work testing water and nutrient delivery systems with hydroponics approaches that we can easily clean out and reuse without taking a lot of media or substrate to space. And so we would like to develop these that'll be independent of gravity. And, you know, other things like LED lights, environmental controls that translate much more easily to all the different gravity levels.
All right, let's go ahead and jump into the next video. This is number 3 of, hopefully we'll get to all 4 today. So Gioia, once again, walk us through this video.
Okay. So this shows our preparation of plant pillows for veggie. So as I said, we want to get into hydroponic approaches, but right now we're using substrates in veggie. We use a baked ceramic with a controlled fertilizer, and we put that inside this plant pillow, which is essentially a space grow bag. And we add these wicks to help draw water throughout that substrate and up to help the seeds germinate. So it's, you know, we spend a lot of time preparing these. Seeds are something we're very interested in. Normally we plant the seeds on the ground, we glue them in the wicks, but we're working on these seed films to allow the astronauts to handle the seeds. And these are going to be tested on the International Space Station soon with our red romaine lettuce seeds. And so the astronauts will take a piece of this water-soluble film with seeds and put it inside those wicks space to hopefully grow some lettuce like this lettuce through in our earlier ground testing. We're also testing a variety of new crops, including tomatoes. And so these are some of the dwarf tomatoes that we're hoping to grow in veggie next year. We've down selected to a variety called Red Robin. That's a very productive dwarf or tomato variety, well in containers. And we're testing a wide variety of leafy crops on the ground. So it's not just red romaine lettuce. We've grown mustards, shingiku, which is an edible chrysanthemum, things like wasabi, which was already tested in space, Mizuna mustard, which is this one. This is Jess Bunchek, our pseudonut for our veggie experiments. And this was our last ground control for the test that we did with the different red to blue lighting recipes on orbit.
So, Gioia, from that video, and then one of the first ones you showed, or the first ones we showed, was there's an interesting topic here about astronauts performing the science. And you made a comment that made it seemed like you were saying that essentially astronauts there are simply executing the orders that your team is providing on how to do this. Is that a fair summary of what's going on up in space?
Well, it depends on the experiment and the astronaut. So we've started by developing, really defined crew procedures to allow them to grow the plants based on the plans that we put together on the ground. But as Scott Kelly showed with the zinnias, the best laid plans don't always work. And so he actually took over what we call autonomous gardening, where he was the one making all of the decisions on when to water the plants and how to change the environment for them. And he did a wonderful job. He was very engaged. We've had other astronauts who've also done an incredible job at growing the crops. And so, if we want to get to the point where they're the gardeners, they're seeing the crops, and they're the ones doing the response. Not everyone's comfortable with that, and so our ground team provides support as needed for the different astronauts.
Yeah, I don't know about you, Philip, but I don't have a green thumb. That's not my thing, so.
Not at all. That's really interesting to think about astronauts as gardeners. I never really thought of that, so.
Yeah, again, very talented men and women, so.
Right, so have they noticed, you mentioned that there's potentially impacts on taste and texture. Do the astronauts, provide you that feedback and you adjust what you're doing based on that? Have you seen those things happen?
We have gotten feedback from the crew, mostly that they want edible crops versus ornamentals. So we're doing a lot more food crops. They like strong flavors, and so that's why we're testing some things like the wasabi mustard or some of the spicier peppers. And we are actually getting official taste test data back from the last experiment with the red to blue light, and we hope to do more of that in the future, where the astronauts actually rate the produce on, the characteristics they like and they dislike.
Awesome.
So I know we're getting a little bit low on time here, so let's go and roll this last video, Gioia, and tell us again some more about what your team is doing. We're not showing these because they're redundant. We're showing these because there's so much work happening.
Yeah. So this is some of our testing of different varieties of crops, and this is our scientists Lachelle Spencer and Jason Fisher, who are harvesting peppers. So we do a lot of variety testing with peppers and tomatoes and leafy crops to really find high-yielding plants that will grow well in the environment of the space station. And peppers are really exciting. They're very nutritious, they're very flavorful, and we are hoping to grow those on the International Space Station in our advanced plant habitat hardware at the end of this year. So this hardware, the APH, or the Advanced Plant Habitat, is actually kind of like Veggie's big sister. It controls all the aspects of the environment. So it's more of a plant physiology research tool, whereas Veggie is a little more like a garden. And we can control and monitor the environment so that we hopefully will be able to grow peppers really well. Here again is our tomato testing, different varieties, looking to see which ones will yield a lot of fruit in a short amount of time with pretty small growing space. And there's a great shot of our advanced plant habitat on Space Station. So unlike veggie, it actually has a door. So veggie is more the transparent bellows, and the astronauts are growing and eating the crops. And we also now have the capability on Space Station to weigh the crops as they eat it. And so this is from Veg04, this is a mass measuring device to weigh the amount that they grew so that they can eat it, but we can still get a good yield of the plants. But really, this eating is our end goal. We want happy astronauts that have lots of nutrition and also really good, delicious food.
Awesome. Thank you so much. So we have two more questions to close out. One, in the long run, how much of the astronauts' diet is going to come from plants that they actually grew? And then one person asked, where can people access veggie research? Is it publicly available?
So we'll answer the last one first. All our research is publicly available. We get the data and publish it as frequently as we can. It takes a while to gather it all together. But NASA.gov has information on veggie, and there's a NASA task book where you can search for articles and things related to veggie. In terms of the percentage of the diet that will grow, we're first looking to just add fresh produce, like maybe a salad a day or a salad every other day, and then we'll build from there. We won't have a lot of space to grow plants, so we're trying to get as much productivity in a small area as possible. And we're even looking at new crops like microgreens, which are really short, leafy crops that can grow very fast and be very nutritious as a short-term solution. But then, the longer that we stay on the moon or on Mars, the more we hope to add to the diet. And ultimately, it'd be great to get to the point where we have like a greenhouse module on the surface of the moon and on the surface of Mars, where the crew can interact with plants if they want. If not, maybe we'll have robotic gardeners taking care of the plants, but providing them the fresh food that they will like to have to supplement the diet.
Awesome. As always, we could talk for hours. There's so much to learn. Gioia, thank you for joining us and contributing to our NASA Social.
Thank you for having me. It was a pleasure being here.
Awesome. And Philip, thank you for joining me, helping co-host today for this show. And I think the next one is yours, so looking forward to that. That will be coming up in just a few minutes. We are targeting 2 p.m. Eastern Time, Hangar AE. This is the telemetry center of the universe for rocket launches. So very exciting stuff. I want to tie this all together and remind you that a big part of what the Commercial Crew program is about, what Demo 2 is about, is developing a capability to increase the science research aboard the space station. SpaceX is only flying 2 people this week, but their regular crewed flights will have 4 crew members on board, both American and international. And that capability, that volume of people is actually going to double our research capacity on Space Station. So a tremendously big win for America and the entire world as we look towards the future of sustained presence beyond Earth. That's going to do it.
Exciting stuff. Yeah, thank you so
Super
much.
exciting.
This was awesome.
Yep. All right, that's it for this time, and we'll see you soon.